Hi, I'm Naima Ahmedlu. I want to present you leader follower task. To introduce this task, I will give you an overview. This task is designed as a seminar task for summer school in 2020 at MRS Group. It is focused on developing a control routine for a follower drone to track the leader in the MRS system with UV-DAR data. The objective of this task is installing open source MRS system and developing a control system for the follower UAV that enable it to track the leader. And the leader is tracking a predefined trajectory. There are some coding files. The primary file, which considers the parameters that will be used in the main code, is the configuration file. It consists of some parameters such as control action interval, UV-DAR interval, desired offset for the formation, and common filter parameters for estimation and initial dynamic reconfigurable stash use using different methods such as state estimation, reference trajectory, or something like this. In the follower CPP file, there are some input data from initialization config and the audiometry information from the system tracker output from the system IMU and UV-DAR data from the UV-DAR system and the UV-DAR data from the system. And the information are getting updated in each interval, and using this information the later state are predicting, and it will be used for having a control command for the follower. You can see here the crude answer. Here is the crude answer. It will prevent following in this point. I used two strategies to make and improve this code. I mean the follower CPP file. What I did was prioritizing the task and using the speed tracker as a default mode, and then if I couldn't have the information, the trajectory reference will be used, or if I could not have a proper answer, it will switch to trajectory reference. And if this mode is not working well, it will use a reference point. In the second strategy, I had a more engineering perspective on the work, and I used the conditional points to obtain a control mode. For example, I use a condition for detect maneuver when the leader is following a curvature and having information of UV-DAR is critical. Creating a reference trajectory is a better point because you can have the start and end point and make some curvatures there. And when there is a sudden movement, it is not a straight path and there are some disturbance, create a speed command will be used, and anything, none of them will be switched to create reference point. I will give you some details about the structure that I use in each of the previous slide. For example, here in this slide, I give you the create reference trajectory detail, in which I use some inputs for this method, such as desired position, follower position tracker, control action interval, and I used cubic spadeline interpolation rather than using 2 points, which was in the crude solution, and I used some intermediate points between 2 points. I used 10 points there to make the solution smoother, and I use some coefficients to make this trajectory. You can see here the answer for 2 points. You can see here It is a very, you know, it's not a good answer. It is not following. It's just coming from coming toward the 2 points, and in the following I will talk about the create speed command. I will use two different methods. PID controller is the first one. I use the desired leader position here, follower position tracker. I use the position error and position error deviation and integral with some coefficients to create a control command. Then I used in the second control method, I used the prescribed controller. I put the reference paper here for the network of multi-agents, a prescribed time consensus, and there are again the error parameters and the mu and mu dot, and h and t parameters are designed in the prescribed controller part, and c are the parameters that will be used to reach a good performance at the prescribed time. I also used some RQT adjustment here. Just want to present you faster. This is my final one of my final simulations. Just I want to apologize if they are not very continuous, because I had some net interruptions and electricity in the high processor computer that I was working with. You can see the result here. It follows a bit and then it prevents. It again follows in some part of this path. Then it goes to the some critical points. You can see here that it follows the ladder, and here it uses the reference trajectory. These are the scores that I obtained along this task. Just I put some of them and one of the highest, and I put you some numerical result to make the performance of the controller more evident. That's how it works. Just prescribed time controller is an advanced controller, and that is useful to reach controller, for example, convergence in 3 seconds, and just it's a very easy and numerical simulation. The first conditions not the same. At the end, I want to thank you for your attention. I hope I could give a good score from your side. Thank you.